So I've just started the recording. I'm just showing off some of what I'm doing to set up my GitLab environment for teaching and also for how I use Unreal. And we're going to talk a little bit about Unreal in this recorded session. I might have to edit bits out if it gets too boring or speed things up, but I'll record it now. And I'm currently streaming this on Twitch, and also we have a connection to Discord. So some of the Twitch comments have come in. People have been talking about JetBrains and and an Inga 302 lecture clashes with this. That's a shame. I will we'll also be recording these sessions so that hopefully you don't miss anything. We'll have tutoring support on the Wednesday, and for the Inga 302, given there's quite a few of you doing Inga 302, we might have to look at maybe moving this session if the comp students find that this is not a good time for this. We might have to move it to the Thursday. Okay, so I'll grab that chat down. Okay, so here you can see I'm setting up issues. One of the issues that I'm setting up, okay, excellent. There's nothing too earth-shattering. I just had a comment in the chat that someone had to leave. There's nothing earth-shattering about this, and I am recording it all, so it'll be up online. Okay, so what we've got is in this course, and I'll be talking about this later today, is that I'm going to be doing an agile teaching process, and as part of that process, one is I'll be trying to keep up with Twitch streaming my process, and I've got good number of you there, and we are using our Git both as a learning management system as well as our tool for building projects. And so as part of that, one of the things that I'm doing is I'm putting my issue topics, my lecture topics, into the issues. So here you can see that I've added the intro lecture, but what we're doing is I'm going to create a new issue which will be one of the AI topics. Now if we have a look, as I was just saying before, the assignment 1, learning Unreal, has been uploaded to here. I will also be uploading this and creating this as a GitLab repo, which will have a git ignore and a git attributes file, so that what you do is you build that Unreal, you fork the Unreal repo from our learning management system, put your Unreal project into that repo that you have forked and is now your own. It has in the README, or the assignment text, we'll call it assignment text, this description, so you've got it connected to your repo. And then that's where you're going to write in your own README to describe what you've done and how your project works, because rather than writing reports in this course, I want you to use the tools that industry use. And industry use Git and do documentation not as PDFs, but as text in READMEs and in repo. All right, so that's how I'm going to get you to document all of your work in this course, is in repos and next to the content. Okay, so here, this is the assignment. What I've got is I've got the lecture text here. This is going to be a new issue. So one of the things I'm going to look at is what the lecture schedule is. And so this lecture schedule that I put up here, this was from last year's lecture schedule. And basically what I'm going to do is some of these we definitely have to cover, and others are in that, well, if we get a chance to cover them, that's what we'll do. Otherwise, you will be able to vote for particular issues. And so what I'm going to do is let's put in the balance lecture, and I really like talking about the balance lecture. But if we put it in here and go balance, and it's a feature that we're going to add to your knowledge. And so here the description is the and as you can see, my spelling is atrocious. Finding ways to make a game interesting by balancing the content. And there's various ways that it's balanced. So I'm going to assign it to me. And we're going to make that a lecture. Right, so this is the process I go through to create issues. And so we're going to make that a lecture. And that... So I'm going to set a due date on this because I want to have given you this lecture fairly early in the course. I'm going to suggest that we either do it next week or the week after. So I'm going to set that as the due date to have this done by. And I'm giving all lectures weight of 2. This is a workload weight, so this is this is story points weighting, right? So these are ways to think about how important an issue is. Some of these things might be 1 point. If they're 4 points, it means I'm going to have to cover across 2 lectures. So AI, for example, might be 4 points, and I might need to put it into 2 parts. So when I create that issue, so the idea here is that we create those issues, and now we have labels. And if I go to my boards, under my issues, I can have open and closed. But then, I can edit the board, and I can add cool div, show open the show, and okay, group by none. I'm supposed to create list from label, select a label, and I could give the to-do list, add to board, and create a new list, which is going to be my done list, add to board. And because I know that I already decided that I'm going to give you the balance lecture because I think it's critical enough, I'm going to directly put that into the to-do list. This gives me the ability to say, well, these are things we're definitely going to do. These are open issues, right? And so the lecture tonight is also in the intro. It will move across when I'm done with that lecture tonight. And we'll move the balance lecture across. And what I'll get you to do is as we start doing retrospectives on what important topics you want to do if I come back to the list of issues, particularly if we go to the lecture list, one of the things we can do on issues in GitLab is that we can upvote them. So I've given that 2, and here, oh, sorry, that's because it was assigned to me. Back. So what I can do here is we can go into balance. And you can upvote it. Right? And so what we're going to do during the retrospectives is I will get people to vote on the lectures and what the most important topic is. And that way, that will determine the order in which I give those lectures. Right? So this is using these issues and the issue tracking in here as a way of managing my GitLab repos. Managing the lecture content, because I have so much I could say about game development. It's so much fun to do game development that this lecture schedule isn't reasonable for me to try and kind of determine exactly what game optimization. The ethics lecture I will put into the to-dos. Now I won't record myself just going through this manual process. I just thought I'd show you the process that I'm going through. You will see all of these will come into the discussion this afternoon, and I will move these from a suggested order. But you'll be able to kind of see how these play out, and we can change the order when AI happens. Is up to you to say, do you want 1 AI lecture? Do you want 2 AI lectures? do you want more content on remote development? So these are questions that the class will answer rather than just me making a decision for one. And also, this is new. Unreal Engine 5 is new. GitHub Copilot is new. The way that networking will work will be new. There'll be lots of new content, and I won't be able to know it all or understand all of it without some help from you all. So that's what we'll talk about in the lecture tonight. So one of the things I thought I might also show off is we have, I won't install that one. So what I do is I won't actually grab that one yet, but what I won't update that while we watch because it'll take some time. And you can see I've got 96 gig across these two already. So I'll start with a launch in here. And I'll launch it because although I've got a bunch of projects and I've been working on projects, I thought I'd just quickly go through one of those core ways of doing development is to launch your Unreal project, and it's actually it's opening up on my screen down there because I've got my multi-screen setup, but I'll move it up here when we're done. What I am doing, and what I will show you also, is that in the COMP313, which has the kind of general project here, and so this is the 2022 year, so this will be the lectures that are going up and kind of some of the discussion around how I manage the project of teaching you. And this is internal, so all of you should be able to get to this project. And I've got a simple Unity project because we had that previously, and a small top-down, and there was an old networking example. We don't have to worry about that. What I can do here is I was going to create a assignment 1 project template, which has the assignment in it, and particularly, as I mentioned, those get, ignore, and get attributes for long file systems. Now, part of the reason to create a good get ignore and to use a get ignore and get attributes is that, as people have already noticed, some of these files are enormous, right? So some of these are very, very large indeed. And so we need to manage how we move these large files around. We need to manage how much is in our on our GitLab repos, because we don't have infinite space in our GitLab repos. And also, if you're using free versions of GitHub or paid for versions of GitHub, the size of your projects matters because you will run out of space quickly. And so we are very keen on working with you to keep the size of your projects low. Okay. So one of the things I wanted to show is how I would set up a Git project, if that's interesting to you. Any comments around that? Do you want me to show you how I would go through this process? This is also useful just to see how I would set up a Git project. This is me very much kind of ad-libbing and showing off my process. Again, useful in some ways. So if I'm going to create a new project, so if you have any Twitch comments saying, hey, yep, no, we're keen on showing off setting up the GitLab repo, connecting it to a new project in Unreal. Because if I go to my Unreal Engine, which has now launched, and I'll close that one. So this is these are my recent projects, but if we look at here, I've got these top-down small. These projects are the most recent ones I've been playing with. But when we create a new project, and often when you're looking at going through the tutorial process for using Unreal, you will start with these game projects rather than to film more events. And this has a smaller number than have been in the past. In the past, we've had a lot of these kind of things with the first person, third person, top down. There's been 2D. There's been a few other example projects. I can't remember exactly what they were. So this is giving us mostly 3D content, and some of the discussion around can I do a 2D game. You certainly can use Paper 2D, which is Unreal's 2D system, and there are projects out there. If people are very keen on doing 2D games, then we can create a new Unreal 5 template for you to use, and I'll put it on the GitLab site for COMP313. But for testing purposes and for a bunch of things we do, you can actually do 3D stuff and make it look to some extent 2D or top down or ortho. And so, which one do people want me to show doing creating a new project from? Do we want third person or top down? Any comments in Twitch stream would be great. I'll also check my Discord to see if anyone's in my office. No one's in my office in Discord. Okay, that's all right. So Twitch stream people, do you have any preferences? There should be 20 of you. Someone should have an opinion. Does anybody have an opinion? Please have an opinion. Which one should I do? Top down, first person, third person, top down. Third person, top down. Haha. Okay, so I've got 2 for top down. Okay. Well, now I've had 3 for first person. What do I do? Okay, I need to have another person to vote. Another person to vote. Come on. So we've got third person, top down. 2 for top down. 3 for first person. VR. I do have my VR setup. Up there, I've got my VR headset. And my stations. I'm in my tiny room here, so I have my towers and stuff set up. So I could do VR, but that's a bit slower. So Twitch Prime gets higher rate. Okay, well, I will actually, I'll do top down. So we'll select top down. And now, do we want to do blueprints or C++? Now, I'm requiring you to do at least one C++ piece of code, either a node in C++, an object that code in C++, or a blueprint function that you add written in C++. So rather than being blueprint only, which can again be converted later to a blueprint and C++ file, if you click C++, you will have blueprints, right? Blueprints are native, and so even though you pick C++, you can do all the blueprint stuff. You can do all the stuff in blueprints. So, so I'd pick C++. Platform, I'm going to stick with desktop. You probably don't want to install Android and iOS because it will blow out your install capacity. And, you know, I don't need maximum quality. Maybe we can go with scalable. Now, starter content or no starter content? This is an interesting question here on whether we do starter content or no starter content. And it's starter content makes it larger, but that also means that you're going to put a whole bunch of useless content or content that you're unlikely to use into your repo, and it will blow out your repo size, right? So without starter content, it's about 600 meg. With starter content, it's about 4 gig. So if you're running some of those 3 things, you've only got a 5 gig limit, then one project with starter content will bloat that out. So I would generally turn off starter content for your projects, and we can call this assignment 1 v 1. Now I'll create this as a V1 because I will probably have to create more versions of assignment 1. So when we, now also you have to work out where you want to put this. I'll be putting it in the COMP313, actually I'll put it in COMP313 2022/code. So if I browse that, you can see here that I've got, I've already done a top-down, a C and an SM, so that's a small version. So there's a small version in my code. I'll jump into the 2022, jump into code, and select that folder, right? So I'll put it into my 2022 and I'll call it assignment 1 v.1, and I'll create that. Okay, so this is creating that project. Now, this project doesn't have any version control attached to it at this stage. Now, what we can do is we can add, we'll be adding the Git repository code to it. Now, there's two ways of doing this. One is we create it like this, and that creates it into a new area with that particular assignment name. The other way is we can already created the folder and then create the assignment over top of the Git repo. But if we just wait for that to actually spin up, so it's created. So what I'll show you here is I will show you copying in the Git ignore and the Git attributes, and then we'll also do the Git initialize. So we'll initialize the repo locally. We'll add that Git ignore file so that we ignore content that we don't want to upload. And there's a lot of content that you don't want to upload, particularly anything that can be rebuilt by the local end of the project, right? So all of the intermediate files, all the build files, all of those sort of things can be rebuilt, and so I would leave them blank and read those. Will be those. So I've clicked the, oh, you can't, that create button there. That was the button I clicked. Oh, you probably, I don't know if you're following my mouse. I'll just turn on my mouse highlighting. I have to remember how, where did my where did my mouth highlighting go? I haven't set it up to restart when I restarted my machine. That's annoying. Okay, so, oh well, I will find that. I'll just see if I can find that. So, so this has.
Hi everyone, Kevin here.
Right. So that is more. Where are we? Auto hotkey. That's the one it's called. Okay, that's freezing out my screen. Let's just see if that actually doesn't crash. Interesting. Ah, there we go. Don't think that crashed my whole machine. And do I have my pointer highlighting? sorry about this. I was just okay. Surprising, I've lost my cursor highlight. Auto hotkey right. AHK. So it's an AHK file. Downloads. AHK. Cursor highlight. There we go. There we go. That'll be slightly better. Okay, so what that project built, what that did is it created this, which is the Unreal editor. So this Unreal 5 editor with, I just screw that down. So the Unreal 5 editor here has the main game engine there. We have the outliner here, and we have the details behind my head. Now, as you can see, this is so I can mouse scroll wheel in and out here. If I click, I can move forward and back and turn left and right. And also I can use when I click, I can use my AWSD keys to move around inside the environment. So that's kind of a moving around, looking at things kind of way of doing things. If I right click, I can look up and down and pan left and right. If I left click, I can pan left and right, but when I move forward and back, it up and down is now moving forward and back rather than looking up and down. Right? So right click up and down, left click in and out, but also look back and forth. And of course, all of these change when you use Shift and Alt. So if you use Alt, now when I use Alt, my left click becomes that instead of moving in and out. And when I use Alt, my right click becomes scrolling in and out, right? Zooming in and out, right? So you've got various keys combinations with mouse that do various different things. Okay, so if we go, close that. I don't need that. So if we go over and have a look at one of these objects. So if I click on this object, you can see here it's highlighted in the outliner, and you can see that this has actually got, there are a bunch of cubes here. These are, if I double click, it'll take me to that cube, and if I control and scroll wheel, so yeah, scroll wheel in and out will also work. So I can see that that's that cube, and we have that cube, and the one way over there. So if I double click on that one, I'll get over there, zoom out a little bit. Okay, so this is an environment. It's also, because I said a C++, it's also created the Visual Studio Code version of the system. And we've got a combination of the way we do version control up here. And here we've got actual get local repositories, and we can do some setting up repos and managing branches and managing commits and stuff in here. And also you'll see that it has pulls and pushes, which if you use git, that works. Integrated into Unreal, there is also a version control system, but it's not as good. Way down here you'll see, I'll just make sure that I can actually see what I'm referring to. So just there, source control is in the bottom corner down here, is source control, and it allows me to connect to source control. So so that will allow me to do these kind of controlled updates and manage the changes I make. Now, to connect it, you have to have created a project that it connects to. and there's various ways of doing that. If you create a external repo, you've got to be a wee bit careful of how it links, because depending on how you create your GitHub repo, you don't want two different heads. You don't want it to become disconnected and start one over here and then start another one over here and then kind of have them as two different. All of that doesn't look very good. So one of the easier ways is either to start a GitHub repo in GitLab and clone it to your local machine, and then move all of the Unreal content into that repo as an initial big commit, and make sure you've got your git ignore and your git attributes, and then commit to the repo you created online. Or you create the repo here, right, on your machine, and then you import it in. You push it up to a remote location, right? So yeah, as we said, there are multiple ways of doing this. We can do a quick short video just on those two different processes. I'm not sure whether I should do the GitHub repo stuff immediately, or we should just plow into it. I kind of see Git, rather GitLab stuff, I see Git as an important part of any kind of development, and so I'm keen to actually use the tools and make sure we've got a proper GitHub system set up. So what I'll do is I'll make some separate videos for that, and I'll video those two processes and I'll upload them so you can see what to do. I've also got to create that GitLab repo in the assignments area so that you have an Unreal 5 version that will work smoothly. Okay, 5.0 version. So, but what I thought I might do is just quickly show some of the ways we interact with Unreal Engine. So as I said, we have, this is just me doing a quick intro. So we have the C++ code, and this is the Community 2022 edition, so I've just downloaded it recently. And this has this is the Git changes are there, so but I'll just close those. This is Solution Explorer, which says we've just got this assignment 1 v1 project. We have engine specific things here, and I have my game project here, which is where my source code, which is specific to this game, right? So we can see that we've got sort of a initial target rules for how we build the project, and editor rules, and this is the Unreal project and the actual source code. So we have a CPP source code here, which you can see we've got H's and CPPs, and there's a lot of actual code in here that is kind of doing its job. And when we add our own C++ projects, it will come in under this assignment 1 area, right? And you can see there are errors and warnings. The errors is that it's core.net. Yeah, these aren't your concerns, so it should be fine. It will generally work past those errors. So yeah, don't worry about that. Though this seems to be a .NET.H, so I might need to update my .NET version. I'll have to look into that. Again, we're doing this on the fly, so it's not already set up. So At the moment, I'm going to do things in Unreal rather than in here. But for this whole project, when we talk about the game source code, right? So this is the config and the source code for programming in a C++ project. The engine stuff, these has got like source code. This part of the project is also important for version control because you kind of need some of these. And under source, you have editor source. So there's a big chunk of stuff in the engine which allows you to see what like how to code and what you can connect to, because you need all those .h's. We're not rebuilding the engine from scratch, so that's more of those lookup information. And when we look at this source code, you can see that it's showing us, relatively minimal set of source code that we currently have that we would be editing. So we're not going to edit this stuff. We're going to go straight into blueprints, and we'll come back to that. So what I'll do is if we just go and jump into blueprints. At the moment, this scene has the player starting there, and they can run around top down. And so if I press play, you can see that I'm a top-down character, and I will move around, and I can have physical interaction with that. That object currently has gravity attached to it, so it's an interactable. These objects don't move when I try and bash into them, so they are fixed position, whereas this has a static mesh that will respond to me. Again, my scroll wheel doesn't change my view angle because I haven't set that up in this game. And remember, there were these blocks over here which I could also run into. So if I stop, so that's, you can see there, and if I wanted to change my position for the starting position, I can move it up or down. I can move it forward and back, or I can grab the center and move it around in all dimensions. So if we, now up here you see this is the move, I've got rotate, I can grab that and say, well actually I want to rotate it round in this direction and have it face that way. So now when I press play, I'm here facing this way. Right? So I'm quite close to these objects, right? So that made it easier for me to interact with those. Okay. Now, at the moment, if I click on one of these, it says that it's a static actor. So how this got added was it got added as a cube, right? So when you insert, you can insert, and you could duplicate one of these, right? So I could go. Where is it? So I can copy and paste, and then if I grab applications, I can see that I've now copied and pasted. I've got a version 6 here, and it has the same static mesh properties as those other ones. And if I scroll down on my features, and if I just find there and move that up so it's a wee bit smaller so I can actually see what I'm doing. I'm partly using my small screen so that hopefully you can see what's going on with these texts being large, because if I use my big screen, then all the text becomes tiny and you might not be able to follow anything at all. So down the bottom here, right, what I've got is, and if I keep scrolling, there we have all of the features that this object has right down the bottom here. And and if I move my details up into here, I can then just click on them, and that way my outliner is now the whole field, and now I'm going to my details. You can move them to the side and move them around, and that's all fine. So, and if I want to find gravity, I could look for gravity, and you see it's got under physics it's enabled gravity. I could turn gravity off, and now if I press play, that is just sitting there, right? These ones, when I bump into them, will fall. This one is just hovering in space because it has no gravity. Okay. Now we can stop that. So that copied on object, put it in there. You can add other objects from if you look under the content browser, you can find. If I'd added the starter content, there'd be a bunch of content in here. You can drag things in from the content browser. There are also the content drawer. If we go to tools, you can create the new C++ class. We don't need to do that. But if I look for where is it? Where is my import content? So so content browser is, so I can add here basic actors or characters or pawns and lights and a player start location. If I don't already have one, trigger boxes. I can add lights and shapes like cubes and spheres can be added in. The basic actor is an object that can be placed or spawned in the world. So you create. There's layers, right? So we have meshes, which are the object, and then we have actors, which contain those. These are all of the type static mesh actor, which means when you go to edit them, you'd be editing every static mesh and the code for every static mesh. So when you probably want to do, if you want to create a specific thing like a trap or a follower, you actually click on this, and let's say we do 6. If I click on that and go to details, right, you'll see, and if I make that a wee bit smaller so you can see it, you can see here we've got edit the static mesh component, which is the standard static mesh system, and I can edit that in C++, which would be changing it for everything in the entire system. That's probably not what I want to do. If I want to edit the blueprint and I click here, it'll say, how do you want to edit it, right? Do you want a new subclass? Do you want to deal with all the children or harvest components and try and create the... If we do a new subclass, we could call the blueprint name, let's call it cube trap, and we'll just put it in game, and we can select that. All right, now what that's done is it's created a new type, a new subclass for this which will be called trap. So this is now an instance of that class. So where did my blueprint go? There it is. It just took a while to start up. Okay, so this then gives us this window, which is a blueprint editing window. This gives us a viewpoint what it looks like, because often what they worry about is what it looks like, and gives you the details of this particular instance, right? Because we're looking at this. We're looking at the blueprint, and we've got an instance version. The constructor script deals with construction. The event graph deals with events that happen during the game, and so we have a begin play, which happens just once. We have so right click to move these around. An event actor begin overlap, that's basically for collisions. and we have an event tick. The event tick happens every frame, right? So this is and blueprint programming, we can drag out from the white line here to say a branch. Let's grab a branch. Now a branch is an if statement, right? So I've got an event tick and I've now got a branch statement which is if, right? So you can imagine in the actual code what we've got is we've got an event tick code. At the engine level, it runs the event tick on every object in the world, and so this object has code associated with that event tick. And if we attach a branch to that and the condition, what condition would we like to? So we need to do something if this is true. Let's go. Now, one of the things I can do is I can pull off the true, and so it currently has gravity turned off. I could set gravity on this object. So actually, it's set enable gravity. So I type gravity, and it's set enable gravity. Now you can actually, so this is all being highlighted together. So if I click away, I can move that just up and down. And this is static mesh component. So the static mesh component is the cube itself. And so that's the target of this. And actually, so currently it says gravity enabled, and it's up. I'll click that on to make gravity enabled true. And this is currently conditional true. What I can do is if I press play here now, boom. Did you see that dropped? And that dropped because I turned on gravity, and you can see here this it's simulating saying that this event is happening every frame. It's coming to this branch. The branch condition is true. I can right click on this and I can't even watch that variable. And it's trying to, and so it's enabling gravity on that, right? So that's if that was always true. So if I stop that, I say, okay, well, what I want to do is I want to actually change that conditional. So rather than, now, so you can see this is an execution line, goes through a branch, continues. If I had false, I could do something else. So let's drag off a conditional. So what we need a conditional? Well, when should we turn on the gravity? On Twitch. What are your thoughts, Twitch? When should we turn on this gravity? Not getting any comment back yet, so I'm assuming that people don't. When our character is close enough, aha! Maybe it lands on your head. Aha! That would be yep. So when the character is close enough. Okay, so what we need to do is if we're going to do it for character is close enough, let's pull off here, and so we need a condition. We need to work out when the placer is close enough. Now this needs to be a boolean. So we're probably going to have a less than or equal to. So let's then go less than or equal to. There we go, less than or equal to. So this is a node that gives us an output, which is a boolean, right? A conditional, and that's why the red line is a nice red line, is because it gives us that kind of I'm looking for a conditional. It has to be of conditional type, right? So boolean value. This could be anything, right? So at the moment, no type defined. What I probably need to do is work out when my player distance is closer than a certain distance to the object, right? So I've got the object in the sky, and so this will be some calculation of and if I right click here, I can convert pin to, let's make it a floating point, because we've got booleans, integers. Let's change it to floating point. And so this is going to be less than. So the world in Unreal is done in centimeters, right? So 100 centimeters is 1 meter. So if I'm within 2 meters, and that includes the vertical height, so within 2 meters, or maybe 3 meters, let's say within 3 meters of it, 2 meters of it, let's go 2 meters, 200, right? So that's 200 centimeters, which is 2 meters. So when I'm within 2 meters of the center of it, I'll do something. And so this needs to come as a value which is some sort of distance value. So distance to player. Do we have distance to player? We have distance vectors. I'll just check if we have player sequence. So distance from camera. So we have vector distances, and what else do we have here? Okay, well, let's say that we are trying to get a vector distance. So we're going to have a distance between myself and the player. So let's actually go. Thought there was a vector player, but distance vector. So this will be a float, which will be a distance vector, and this distance vector will calculate off. So this distance vector. Now this 200. What I've got there is I've got a magic number. I'm a programmer. I don't like magic numbers. That's a magic number. What should I do with magic numbers? What do people suggest we do with magic numbers? Turn them into variables. So if I right click this, I can actually go promote to variable. Sweet. And now it's a variable. So this is now a variable, and it's over here, and I can rename it. And I can rename it to being trap distance. Okay, so I'm renaming that trap distance, and that's now a variable. Interestingly, this wee thing here says whether or not this is variable is public and editable within the instant manager of blueprints. What that means is when I have an instance of this blueprint, I can change that value in the details, right? In this detail section above me, I would be able to see that variable and change it for each different trap. I wouldn't have to go into the code and change it because it's kind of been made visible outside of the blueprint. Okay, so just like you would have as a value that you might pass into a function, this makes that variable visible to the outside world. So what distance vector am I looking? I'm looking for the distance between me, one vector, my location, and the player's location. So if we do drag this one off, and this needs to be a vector, so let's look at location. So get actor location. Yes, that's location. Oh no, it's transform location. We don't want that one. So here I'm going to grab a, let's see, static mesh, get location bounds, box, get world location. Yeah, get world location. That looks like a reasonable thing to do. So get world location of the static mesh component. So that static mesh component is actually, remember over here we had the static mesh component. That's actually the same static mesh component. That is the world location of my box, right? So where my static mesh is in get world location, and I put it in there. Now I want to get world location of someone else. So I can go get world location. Of a static mesh component and change the target to the pawn. So okay, player. So maybe if I delete those two, so that's probably so here. So that's giving me my location. I need to do, so I need to get this, and I should be able to get player. So here I'm actually using context sensitive. So actions, because this would be actions that result in a vector. Get player pawn. So get player pawn. So the player pawn is that we thing I'm controlling, right? So and it says player index 1, which is when you have multiplayer, your other players are in an array, and so this is the player index 1 is the current player, and all the others are other in the multiplayer. No. This is the correct trigger to pick. So so here this returns a value which is a pawn object reference, and so now I go location, and what have we got here? So we've got too many. Get location from entity. So we could try that one. And we put that into object reference is not committed to Blackboard. Oh, that's a Blackboard entry. So I don't need Blackboard. I need this to location. So pawn. That's not giving me what I want. So I found this easier the other day when I was doing it without doing it as a live coding exercise. So here we need to I would have thought get world location. Get player pawn, right? So that is the get player pawn, which is what I want, and then that return value should be able to go into location, and I should be able to set initial location rotation physics. Get location. I'll actually make it look like I'm actually looking at the thing because of where my camera is, and I'm looking at my stream rather than looking at the thing. So let's have a look here. Get target. So there are lots of things that I could try and get this from. But that should also be able to go location. Now, so one of the things that this is showing is that you do actually need to search a bit and read a bit. So inverse transversion, we are looking for rendering transformations. Context sensitive. We'll turn it back on context sensitive, and it'll try and give me ones that get actor location. And get actor location. That was the one I was looking for. So I had to turn back on context sensitive to see what we actually wanted. And so getting an actor location. So the player is an actor. Its pawn is that actor. So that player comes in here and gives us a return value. Now, one of the nice things I can do is I could actually turn on here, watch this value, and it will watch that value. I can turn this on and watch this value. And then we can see what those, it will give us a return value and turn that condition on. Right, so that's all I was actually looking for. Now, this is still quite ugly, and it's before the tick event, and there's a whole bunch of like, why if I just throw in this code together? We will refactor and clean that up soon. These should be cleaned up so that they are following at least some convention around how you would want to these to look in the end. But let's see if that works. So in the simulation, we can see that it's going through to here, and we have those are our vectors there. Let's watch that value. So the distance is 5 meters. I'm 5.6 meters away. So let's have a look. If I drag that down, and we drag that up so I can see it when I drag this down to here. So that's where I'm currently standing. And you can see this number turns to 7.5, so I'm moving away. Let's move towards. And let's see, can I get within 2 meters of it? Nope, it looks like this is so far up, it's about 4 meters above my head. So I'm going to have to change some value here. Right? Now I can stop that. And one of the things I can do is I could actually click on this, and because you remember how I made this variable in this trap distance a variable, if I actually go back to instead of the blueprint, and I'll just save that blueprint. And I move that down. If we look at the details of this object, and I remove gravity, I can look at trap, and I've got that trap distance. So this is actually in here under one of these. Let's see, transformations, advanced, default. Under default there is trap distance, and I can now set that to, let's say, 500, because I knew that that was about where I'd got to. So I set that as 500, and now I can press play. So this instance of that will have its distance set at 500. If I click around, oh, there we go, it now dropped. Okay, now that was, I was a bit too close to it. What I should do is I should probably calculate the distance removing the Z, and so make it when I'm actually standing underneath, because at the moment it's using that Z height as well, and that Z height isn't useful for a trap. So if we stop that and click in here, we can see that we actually have X, Y, and Z. Blue is the Z height, right? So and we've got X and Y location, and we've got, oh, it's actually it's moved the scale instead of the location. Oh, that's that object. I mean this object. So here you can see we have its location in space. It's been rotated a little bit, and it's got default scale. So this is our height. Our height above the ground is 5.25. Yes, 5.25 meters. So it's 5 meters because it's 500 centimeters. So that's the height above the ground is 5 meters, 5.5 meters. Now the height of my body was about the center of the character is slightly in the middle of the chest, which is why it still worked to be about 5 meters before it cleared it. Now what we want to do is actually just use the XY. So we would go back to the blueprint and go, well, okay, so you know, I've got some layout issues here. This is all looking a bit ugly. What I would do is, you know, when we teach you to do programming, one of the things we do is talk about comments and things. So this whole branch, this is actually this is the conditional inside the if statement, right? What I could do is I can actually add comments to code. I can add blocks to code. We can make the code look prettier. So and if you highlight, you've got these interesting hide unrelated, which makes only the things that it directly cares about, this particular node cares about, visible. But if we look, we can, we've got all these other things here, but we're, oh yeah, well, I'll deal with that later. So what we'll do is how would we get, seeing we've got these two vectors, if we're only interested in the XY component, we'd need to take those returned value from getLocation, that vector, and strip out the Z value. So one way of doing that would be to multiply the vector, so that we'd multiply for this comparison here, we want to take this distance calculation, and a couple of options. We could make our own distance function, which we could code up in C++, which would be an example of you using C++ in your assignment. Or we could use blueprints, zero out the Z value, and then pass it into the vector distance. Or potentially we can use a vector 2D distance, but we'd have to try and tell it how to which two of the vectors coming out of here, because we need to separate this out into its components. So one of the easier ways would be to add in a vector multiply. So here, if I go mult, I can go multiply, bang. And it goes, oh, okay, so I can see now what you're trying to do is actually multiply two things together. And what are you multiplying? Well, we're getting the output of this going in here, bang, and I'm going to multiply this by 1, this by 1, and Z by 0. Okay? And I can do the same here, where I draw that out. Now there is a way of doing it automatically, but I've forgotten the key for inserting a node between two. So this comes in as the top value, and my multiplying is 1, 1, 0. So now what that's done is it's multiplied the Z value of both of those by 0, so it's zeroed out that and then uses the standard calculation distance. I could probably do a 2D calculation and there's another value to separate out the vector into its components. So that would be another way of doing it. As you know, there are many ways. So if I pulled out this and go components, there is, where is it? Material transformation. There is one which separates it into its components. I could Google for it, but at the moment this should do the job. And now I can actually also, we can watch that value. So let's press play. Now that's 3 meters away. Oh, and it dropped. So you can see that that's dropped because I'm 3 meters away, so it automatically dropped. So what I need to do is I need to change that. So say, well, okay, when you are now, when I have a default of not 5 meters, because that included the height above the ground. Now I'm just looking at the XY location, and so this would be, let's go 50 centimeters. Let's say when you're, let's make it 20 centimeters, right? So you've got to be standing pretty much directly under the center of it. before it will fall. Let's give that a go and play. Okay, so now you can see here we've still got this and it's doing that. If we look in that, we've got I'm 3 meters away. So let's have a look as I move. 2 meters away, 80 centimeters, 70. Bang, boom, and landed on my head. Sweet, landed on my head, just like you'd expect. Okay, so that is me doing some of my editing, and you could see how I worked through the process of what would I do, how would I do it, how would I create that graph to do the right kind of thing, and you see I had to work through those different aspects of the program. Now what we've got here is if I stop that simulation, I could do other things. I could add forces to this so that it would chase me or run away from me, or I could do a whole bunch of different things to make it so the compelling gameplay of a thing landing on your head. What you could do is I could add a health bar. I could add health to my character and then have the thing when it hits me, I lose some health based on the velocity. So you stand underneath it and the trap falls on you. I was actually playing yesterday with having the object track you. And that's kind of actually fun to have things charge at you. Once they can see you, they move towards you. And so you can imagine, to work out how to move towards the player, is that you, instead of turning on gravity, you add a force, and the direction of that force is the direction of the player. Right? So you do a subtraction between the player's pawn position and your pawn position. You subtract those two, that gives you the vector towards the player, and then you add a force in that vector. Right? So you get those sorts of things going on. Okay, so now in terms of the cleaning this up, right? So this is not as messy as some might be, but there's lots of things we could do to this to clean it up and make it look a wee bit prettier and make it easier to manage. So at the moment I've got this is all being visible. What I could do is I could highlight that lot, and then when I right click, I can collapse nodes, collapse to functional, collapse to macro. So so that would, the collapse to macro collapses it to a single node, and that single node is then, I could actually say give it a name, and so that this would be a Boolean check of player standing under trap, right? For example, if I double click on it, it would go into that, and I could actually see that code inside. So it's a bit like, kind of, it's not turning it into a full function. It's just kind of hiding it so that you can show at the top level diagram your main things, and then the sub diagram a macro that just does the player underneath me, right? That might be a bit too kind of compressed, so I probably would want to unmacro that. So we'll just undo the macro. So because this is a variable, I might want to say, this would actually be more converted into this bit into a function, so I could still have the less than to show that what I'm trying to do. But there are various ways of compressing these into functions or macros, and therefore be able to kind of minimize the view of it. We can also add a create comment from selection. So if I do that, create comment from selection, creates this comment box which surrounds that selection, and so this is distance to player, and so that would be a comment box. And so this would just be like adding comments to some of your code, right? And you can actually make the comment box larger. You can move it around. This is basically sitting over the background. Okay, so that allows you to do comments. It allows you to compress nodes. It allows you to turn a set of operations into a node. If I was to create a C++ function, I could create a C++ function for this. We're already at 1:45, and I've still got to go and put all my lecture notes together. So I'm going to stop before I use up more of my time than you want to give me. But hopefully for some of you who were watching along and seeing the recording, that was interesting. Just to see me floundering around and trying to work out how to do stuff. But in the end, the code looks kind of similar. Like the player position, my position, work that out in the world, get just the X and Y components, find the distance in X and Y, put it into a trip distance, and apply that condition to a branch, and if that's true, do this thing, right? Now, this, however, is polling, and so every turn, every cycle of the game, this is doing that calculation. That's not particularly efficient. What might be more efficient would be to add an event collider. So what I'd do is I'd actually add a trigger component underneath the box, right? So rather than the box having to check and look, hey, are you underneath me? Are you underneath me? Are you underneath me? Are you underneath me? I create a trigger element in the world saying this is a trigger element. When you collide with the trigger will tell the box to turn on gravity and fall. Okay, so this is putting the onus on the box to be checking the world. But what would be a different and potentially better way of doing it would be instead in here to have added through here a where is it? Trigger box. Alright, so if I added a trigger box, which was there, and we can see that that is I think directly underneath that, and you could check the location to see its X location is 140, 2.5 in Y, so X is 140 and 250, and this is why is that location not the same as that location? So that trigger box I've just added, I could actually make that trigger box connected to this object. Actually, if I look at from above, let's, I can actually, you can change this to top-down view. And then I'd be able to find actually no, sorry, that's the navigation mesh. Oops, I don't want to be changing that. There's the trigger box. So I want that trigger box to sit directly underneath my real box. So that would be my trigger box. One way I could do that is either move it to location, or given I've got my outliner, I could actually take that, and you see this trap box is now different. If I put that and drag it and child it underneath that box, that means that when I move this box, the trigger would move with it, right? So that would be, so this now has attached that trigger to the box because I put it underneath. So I wouldn't have to kind of try and update them together. And then having attached that, and go back to perspective. So right, the light suggested it's not directly underneath, but the top-down view suggested it was directly underneath. Let's see, what have we got? Details on the trigger box. So if I set that as 0 and 0, that should actually be, that will be the left-hand corner probably of the box. So this is the Z, how far below the box it is. And so it's currently at 115 because the box is sitting up here. And now we've got that. See, so when I move those, that moving up and down, moving back and forth, it's now sitting underneath there. And then what I do with the trigger box is, so with this, I would edit the, I'd go into the trigger box itself, and here is where I would add when the player walks into this trigger, what does it do, right? So that would be a different way of handling it, and probably more efficient because the trigger box now as a visual object, I can see that it's being triggered, and the game engine knows to only check that when the player is close to it. And so I'm not using a random function for me doing clever things. I'm saying, okay, what would the game engine like this to be? Okay, what would the game engine, what would be the default way of doing this in the game engine? And it would be to use a trigger, and I'll put that down there to the floor. So this, I'll just see if I put, let's see, it's directly below. So I'll put it down and I'll put it just above the ground. So that trigger point will then, that trigger instance I would use to, now I haven't played with trigger instances because it's collision presets trigger, simulation effects, and where is the overlap method during. So this is when to test against the trigger, and checking advanced relocation. So what I do is, to work this out, I just Google, how to use the trigger system, and it will be an actor can be damaged. There'll be a way of connecting this trigger to an actor. So is this, the actor can be damaged, and it lies spawn, convert actor, select type. Nope, that's this actor. Physical leader in streaming. Where is the connector to target? Oh well, we can Google that. But if I press play, that should, So I would be able to. That will still fall on me. But I would have triggered that trigger that's in there underneath this object, that's below it, and then when that object moves, that trigger will move with it. So you have to decide, is the trigger connect to the object, or the trigger connect to the ground? So those are the sorts of things you'd make the decision on. And I could find this other object and attach it to this trigger. So in one of my sessions, I'll do that for all of you. And we'll show how that works. Okay. Well, I'll stop recording.